Here is Netflix's definition of this field as consumer science. I would call it consumer data science. And I pointed out that what they call consumer science, I call lifestyle informatics. Um, so how do you do this? Well, you have a hypothesis, and I have a nifty algorithm, or I have a unusual collection of data, putting two or more pieces of data together, and that particular choice will increase the in this case here the member of Netflix engagement with the site, and that's important for keeping the user tactically happy and also making the user continue to be a Netflix customer. So you have these two slightly competing goals. You want to do something in real time, which happens now, and you also want it to happen on a long time scale. And so you have a hypothesis, you write some software, and decide on how best to test it, what the important things it might depend on. I mean, if you're going to have a hypothesis that involves, say, a particular ethnic group being enhanced, you better test it in a circumstance which has that ethnic group involved. Then you actually decide these hypotheses are actually answered by the data itself. And Netflix and the other companies that use recommender engines are always improving their recommender engines by letting them run and seeing how they execute. And then they choose the ones that do well. And presumably some might do well one year and not so well the next year, and so on. And the data itself tells Netflix and tells Amazon what works and what doesn't work. Same is true, of course, of Google and Bing on search. So here's an example of how Netflix used a particular piece of technology, Cassandra, which is a so-called NoSQL database, which was able to gather data and make on people's interests in movies, and it allowed it to predict that a movie I'm not familiar with called House of Cards would be a success for it. And so this was an example of quantitative recommender systems being used to motivate the business model of this company. And this, of course, is just one example of what we know supermarkets do the whole time. They're always deciding how to stock their shelves by what people buy. This particular slide gives one example of how, come from the web, of how Netflix was able to predict that a certain movie would be very popular, and it used that prediction to decide to purchase that movie and make it available on its site. And this is not related to how people stock supermarket shelves, for example, except it is not looking at what people did in the past and using that to make certain they have that capability available now. It's looking at what they did in the past to predict how they would relate to something totally new. And they looked at 33 million users. They used a piece of technology called Apache Cassandra, and they used that data to be able to make this prediction. So this is a very good example of data-driven discovery. Another important issue here is so-called A/B testing, which is what Netflix and others use in testing their recommender systems. And it's generally a technique used for effectively testing new websites, whether that's just be a look and feel of the website or maybe some nifty new algorithm buried inside that website. And the A/B testing, it just comes from two versions. You have a version which has the new algorithm in it, which is version B, and then version A is the old algorithm. And you basically look at the performance of the new algorithm compared to the old algorithm. So that came from Wikipedia. In this world we live in, sometimes the best description of something is Wikipedia, and it's often worthwhile going there to see if it has a good description. In this case, its description was pretty reasonable. We do have to decide what we're going to measure, because I pointed out that you're really looking at the long term, not the short term. So, so that's an important part of the so-called experiment, how you do this test. And it points out here that in Netflix, we have multiple different places it's done, the testing is done, and they involve, the new technology is involved on many thousands of Netflix customers. And because Netflix is so big, they can be testing many different ideas at the same time. And as they say, this means that your decisions on a product are always data-driven. They're not driven by the hunch of a particular product manager within Netflix. And here again stresses what I've said many times already. There is not always the short term and long term are not always a good criterion. For instance, if you're looking at clicks might mean that what you were providing was dreadful, so people click to get away, in which case those people will not come back. So what counts is the long-term user satisfaction. Do the people involved with this new technology spend more money and watch more movies at Netflix? And say, according to this slide here from Netflix, they basically use member retention as the criteria for success. So they can actually produce plots here, and here we have an algorithm, and you can see that something happened at a particular time, and there was a big drop, and you have to ask what caused that. And so the new version was clearly less successful. The control, which is the blue top line or black top line, is clearly better than the new one for this particular day, whereas on all other previous days there's very little difference. So that somebody would have to work out what that means. Maybe the software broke or something that day. After this discussion of A/B testing, we'll just make a few end remarks on the software environment. This is seen in this graphic, which shows from this tutorial some of the technologies used in Netflix. We have Memcache, which is well-known in-memory database technology. Java, of course, most big data software is written in Java. Cassandra, a nice NoSQL database. Hadoop, basic processing capability. Remember, Netflix is always run on Amazon Web Services. Teradata is a database solution. Hive is SQL on NoSQL substrate. Jenkins is a testing environment. Tomcat is a server environment. Apache is this sort of organization that does a lot of these software projects. Linux, of course, is the core technology used for the servers. HTML5 is the display technology. And one of these symbols I never could track down. It's got a picture of a compass, which looks like Safari, but I don't quite know why it would mention Safari and why it's also in a cardboard box. There's another diagram here from some different presentation about the architecture of Netflix. Pointing out many of the things it has. If we go up to the top here, we have Cassandra. There are several on Cassandra. Then we have Hadoop. workflow orchestration and logging. Those workflow is how you link together different components of the whole system. Logging is of course necessary so you can find out more about what's going on. Zookeeper is a critical technology um, in these systems. It was originally came from Google, and well, at least the idea behind Zookeeper did is how you do concurrency control on these distributed systems. Here we have Memcache, which we saw on the previous slide. Um, Discovery and finding out where things are and what is obviously important. I must admit, some of these are not so easy to know exactly what they are. Notice these green ones were not actually deployed at the time of this talk. There was the blue says an Apache contribution. I think that means things they've contributed to Apache, because Cassandra is certainly an Apache project. Auto scaling is critical because that's how they get they deploy more servers when they need to do more work. Here we have a logging technology, and robustness is obviously very important. And you'd have to go to look in to find out in more detail. But this is an example of the richness of the software environments. And a lot of these are done open source, and you can just find them on GitHub. And then finally, the comment in this tutorial is that although these are collaborative filtering and other algorithms, machine learning algorithms are critical, then algorithms do more than actually predict ratings, but there's more to predicting ratings than algorithms. You have to have a great user interface. You have to give feedback back and forth between the user and the system. You have to have this ingenious A/B testing idea so that you can actually see which, because there's no theory, and so you can't actually know you rarely know in principle exactly what's best, but you just do these continually testings to find out which of the various approaches actually work. And then you need these complicated architectures living on clouds, putting together all these projects. We have another course in this, which we expect to have in this data science certificate, which will actually go through these systems and architectures based on what's available on Apache. So that's the end of this particular unit. There will be 2 more units on recommended systems going into a little more detail on some of the core technologies. Thank you very much. This is Geoffrey Fox ending this unit.